Alright, welcome to Unit 9 Probability. This is Day 1 Conditional Probability. What you're going to see today is just probability of dependent events, how they interact together. Mary wants to take this is the warm-up by the way, Mary wants to take 7 different classes next year. Assuming that each class is offered each period, how many different schedules could she have? So her first period could be one of 7 classes. And her second period, now that she's already picked one class for her first period, now her second period could be one of 6 different classes. See, it's not 7s for each period. And then it goes down to 5 for her third period, 4, and so on. Now, the answer here would be 7 factorial, is how I often see the answer presented, or you could actually answer with 5040. And that's typically how I'm going to be seeing it on tests and in the book and stuff like that. They'll actually give you a numerical value. All right, moving on, warm-up number 2. Player shooting free throws makes 17 of 20 attempts. Determine the probability that the player will make a free throw and also the probability that the player will miss the free throw. So for making the free throw, that's just simply he had 17 favorable outcomes out of 20 total attempts, total events. So that's actually going to be 85% for him to make it. Pretty straightforward problem. And to miss would then only be 15%, just making sure that adds to 100% since there's only one of 2 things that's going to happen here. All right, usually you're going to see me answering with percentages in this unit. Alright, conditional probability, as you can see right here, is the probability of an event given that another event has already occurred. So given that A and B are dependent events, if they were independent events, their probabilities wouldn't impact one another. The conditional probability of an event B given that an event A has already occurred is defined as this outcome right here. What you're going to see is, it's pretty simple in practice. Carolina rolls a 6-sided die. Alright, so everything is going to be divided by 6 here. What is the probability that she has rolled a 3, given that she has rolled an odd number? Just to make a couple notes real quick. The given event, which will be my A, is that it's an odd number, and that probability is 1/3. There's 3 odd numbers on a 6-sided die. And that was 3 over 6, which, sorry about the mistake there. The probability of rolling an odd number, there's 3 odd numbers on a 6-sided die, that's 1/2. Got a little ahead of myself there. You always have to take your time with probability, or at least I do. That's going to be my given event. It's given that Carolina has already rolled an odd number. Now, the probability of rolling a 3, that's going to be my B event as this is written. And there's only 1 3 on the 6-sided die, so 1 out of 6 is its probability. Now, let's go ahead and calculate this. The probability of rolling a 3, given that she's already rolled an odd number, is going to be 1/6 divided by 1/2. Which is equal to 1/6 times 2. I reciprocated the bottom fraction to 2 over 1 to multiply by it. And 2 divided by 6 is 1/3. Or 33.3%. And that's the answer for this first example. Some people approach it this way. Personally, how I did it as a student, I always considered how many odd numbers there would have been. But there would have been 3 odd numbers, and only one of those is a 3. So 1 out of 3 odd numbers. Now, this is the proper way to do it, and we're going to stick to that through the notes, but realize there are other ways of counting these out sometimes. Unfortunately, a lot of times with probability, you'll get asked problems about decks of cards. And if you aren't familiar with decks of cards, that's going to be kind of a hindrance for you. Just a quick explanation. There are 4 suits, and each of those have your face cards and cards 2 through 10, as well as an ace. So that's where the 52 cards are coming from. Each suit has 13 cards in it. I'm going to allow you to hopefully look at a deck of cards. You can ask me if you've got any questions about what is a deck of cards, what are these terms I'm using. But a lot of the problems deal with decks of cards. Anyways, Chen draws a card from the standard deck of 52 cards. That's the deck I was just talking about. Find the probability that I drew a king, given that he drew a face card. Okay, the given event, probability of event A, the given event here is that he drew a face card. A face card, now, there's going to be a king, a queen, and a jack. And that's 3 face cards for each suit. Well, there's 4 suits. So that's going to make 12 face cards total in a deck of 52 cards. Now, if you want to reduce that, you're more than welcome to. I'm personally just going to leave it alone for a moment. Probability of the event that he gets a king. All right. Well, there are 4 suits, and each suit has a king, so 4 kings out of 52 cards. Now, let's take this event and divide it by this previous one. That 4 out of 52 will get divided by 12 out of 52. Now, the convenient thing in this problem is that the 52s will actually cancel, because if I reciprocate the denominator, 52s cancel, I'm left with 4 over 12, which is simply 1/3. And again, that's 33.3 repeating percent. All right, and that concludes this problem. All right, here's just something more to write into your notes, that what a contingency table is. And you can see a contingency table actually down here. It records data in which different possible situations result in different possible outcomes. All right. Each value represents the relative frequency of an outcome. So in this case, there's 342 boys planning to go to college. That's the relative frequency of that outcome. These tables can be used to find conditional probabilities, and I'll show you that now. All right, it's really popular for the state of North Carolina to use contingency tables. So let's go ahead and take a look at how it's used. Find the probability that a student plans to attend college after high school if the student is a girl. Usually what I like to do is put totals here on each of the columns and the rows. So 342 plus 151 for boys, there's 493 boys here. Let me go ahead and get my pen here. So I'm going to make my totals for each column and row when I'm doing this kind of problem. Total number of girls is 514. Total yeses would be the 342 plus the 376, so that's 718. And total no's would be the 151 plus the 138, and that's 289. Now what you should always see here is that these yeses and nos should add to the same number as the boys and girls. So if I were to do the 493 plus the 514, I get 1,007, which is the total number of responses that we had here. And if I do the 718 plus the 289, I'd see 1,007 as well. That's not 2 separate 1,007s, that's just 1,007 responses here. Now that I've done that, everything here that I could be asked is pretty straightforward. So, find the probability that a student plans to attend college if the student is a girl. So, planning to go to college, yeses would be 376 out of the girls, out of 514, 376 over 514, the total number of girls. Now, if I type that in, I'll get it as a decimal. And I'm going to get 73%. All right, that's my final answer.